Hello, and welcome to another episode of Solving Advent of Code in Rust and trying to learn Rust in between. I'm Eugene. We have.
We have Luciano? No, I'm Roberto. Luciano is the
And
other one.
Luciano, yeah.
Sorry, I'm a bit confused with the location of everyone. Right, so thanks everyone for following along. Thank you for joining. If you never did Advent of Code, it's basically coding challenges that are published every year in the Christmas period, so December. We're working towards reviewing 2021's ones. That sounded weird. Okay, we're reviewing the ones we did for 2021 right now. You can find them on adventofcode.com. There's a banner for them there. We publish all of our code on GitHub. Thank you for the banner. And we publish all the recordings on YouTube. You can find a link to YouTube in the description of the Twitch channel. And in the description of the YouTube channel, you can find a link to Twitch in case you're watching us there. So last time we reviewed the first exercise of 2021, and I think we're going to do the second one today, correct? And Luciano's driving.
Yes.
Meanwhile, hello to Tommaso and Podge. Thank you for following us today. Now, let me share my screen and remove this banner. Okay, so we already have a PR, as Eugen said, that's here, that we were actually doing while Advent of Code was on, just before Christmas last year. So we try to keep up a little bit, and we have a bunch of PRs for all the exercises up until 21, I think. So we'll be mostly reviewing for the next few episodes all we did, and then we'll try to finish the remaining 4. So the next one is exercise 2, and let's try to have a quick read at the README because I don't even remember what this one was about. Okay, so in the last one, we basically got the submarine and we were trying to map the depth of the ocean or something like that.
Yeah.
So in this one, we are still in the submarine trying to do things with it. So we need to figure out how to pilot the submarine. It seems like the submarine can take a series of commands like forward 1, down 2, or up 3. For instance, forward X increases the horizontal position by X units. Down X increases the depth by X units. Up X decreases the depth by X units. Note that since you are on a submarine, down and up affect your depth, and so they have the opposite result of what you would expect generally. So down goes up in a way. It brings the depth higher, and up decreases the depth. The submarine seems to already have planned course, which is our puzzle input. You should probably figure out where it's going. For example, forward 5, down 5, and so on. That means that your horizontal position and depth both start at 0. And if you look at this input, the step above will then modify them as follows. So forward 5 adds 5 to the horizontal position, down 5 adds 5 to the depth, forward 8 adds 8 to the horizontal position, and so on. So we have these 2 axes, and depending on the command, we will move our position respect to the axis. So after following this instruction, you will have an horizontal position of 15 and a depth of 10. And if you multiply them, that produces 150. So now the exercise is that we need to simulate the movement that we get from the input and figure out what is our final position. And the output of the problem will be multiplying the horizontal position and the depth that we get from that simulation. Is that clear or not?
Yeah. We have to move up starting from 0, 0.
Yeah.
Perfect. So let's see what we did here because I don't even remember. Okay, so the first thing we did is to create an enum to try to map, let's say, our commands. So the things
to
that make us move.
To parse the inputs.
And we call them instructions. And it's interesting to see that every variant contains a usides, and that will be the amount of movement in that direction. So up and down and forward. Now, what do we have here? We have, actually, let's have a quick look at the input as well. So it's pretty much like in the example, just much longer. It's like, yeah, probably 1,000 of lines. Pretty much 1,000, yeah. And what we do here is that we have a from string for an instruction, which is basically parsing a line here in the input into one instruction. So this from string is basically saying, take the string, which will be one line, split it once on a space. Then if we cannot parse it, just return an error. Then we take the amount, which is the first part, and we parse it as a usides.
Is the second part or the first part?
Sorry, it
Is the
should be the
second part.
second part. Yes, so
Yeah.
instruction type and amount, we just split them here by space. Then we reassign, like we reshadow the amount value just by parsing itself. And if it's an error, we return the error.
I think we assign it to be a usize instead of a string, right?
Exactly, because here they will be 2 $str.
Cool.
So string references in both
So
cases.
you can shadow the variable with a different type, keeping the name and obviously losing the reference to the old one.
Exactly. You can do that only if you use let again. So it's like you are redeclaring the variable.
Okay.
Yeah.
And this is a common stuff to do in Rust, or is better to keep different names?
That is a good question. I've seen it used in a few places, so I assumed myself that it's not a bad practice. I don't know. Maybe somebody can say to us, don't do that for reasons. If you know reasons, please let us know.
I assume in bigger code bases it can become confusing, but for this case it's pretty clear.
So yeah, it's use the one line above the other, so
Exactly.
you have all the code under your eyes in one shot.
Yeah, I found it. I don't use it a lot. Where I find it useful is cases like this where you are basically doing parsing steps, and you have that intermediate value, like amount here, that is there just because it's convenient to come from a string split.
Otherwise you have to call it like raw amount.
Exactly.
And it starts to be raw everything. Then you have to do 3 passes and this raw amount.
Pretty much, yeah. So that's the amount, which is the second part. We just parse it to usize, and then we use a match here to see if it's up, down, or forward. It will create the 3 different variants and pass the current amount. If it's none of them, this is an error.
We have a question from Tommaso, by the way, around the error types. As in why it's string.
Good question. Static str.
String.
I think this is a good suggestion for improvement. I suppose I was just lazy when I typed it out. I didn't want to do the static str for, I don't know, maybe I didn't think about it. That was the most natural to use a string.
What would be the advantage?
For the error messages, you mean?
Is it just to not redeclare the thing every time you go through here, or?
So I think there are 2 main advantages. The first one is that this one is allocating every single time because it's allocating a string in the heap. The second one is that, like, literally, if I understand what Tommaso is suggesting, let's do it right now. We could do literally this, which saves us also a little bit of code and makes it.
Import it in other modules if you define it that way as well, and then you can check if it's that type of error, or?
Don't think it matters, to be honest.
Okay, I'll let you do it and explain along the way. Sorry for the interruption.
Static, we need to give it the lifetime, yeah. I think that's it. Now, why is it complaining here? Unnecessary closure. Oh yeah, because here now we can just return this. So it makes it even, no? Doesn't do what I think it should do. So why it's an unnecessary closure?
He's trying to auto do something, or?
Unnecessary closure used to substitute option none, which is on by default. I don't understand this one, so we might want to come back to this one later. Let's continue with the explanation, and then we'll.
Yeah, Tommaso says okay or not okay or else.
Okay.
Okay or OR.
Oh,
So drop the else.
interesting. And we just do this, I think, at that point. Doesn't need
But we
to
don't
be.
have to
Okay,
return
fair
an
enough.
error. Okay, yeah.
Yeah, so okay or else it's like a lazily executed function that will be executed only in case of this is not okay. How do I get the default value? In this case, the default value is allocated anyway, but because it's a static string, that's going to happen anyway. So yeah, that makes more sense. It saves you from executing an additional function, and it's more concise. Thank you, Thomas. That's really cool.
But also Tommaso was also saying if you have to add parameters to the error message, it makes sense to go back to the string, because if you have to interpolate at runtime, error, I can't parse this, and you put in this the line that you're parsing that is changing at runtime. So at that point, it makes sense to have a string. But we are not doing that, so it makes sense to have a static str.
No, for our case, yeah, we're being a bit lazy.
Yeah, no, fair enough. To be honest, I still struggle a little bit with this static reference. It's something that you can use and it works most of the time, but yeah, I don't understand, I think 100% all the implications in all the different use cases.
Yeah.
So I go with string just because it feels more comfortable to me, but it's good that, yeah, Thomas is pushing us to do different things so we can experiment more. Please keep doing that.
My approach to lifetimes is throwing them in and try.
Okay, so I think that's clear enough. So this is just a utility that we have here. So we can basically take a single line of our input, do .parse, and we get back one instance of an instruction. Now we have another struct which defines the position of the submarine, and there is an horizontal position and a depth. Both are usides. Then we have a bunch of helper methods.
Okay, we have members of that class. That is not a class, but let's call POSA class.
Struct, yeah.
Yeah.
Now ignore this one because I think this is used for part 2. But this one is... this is actually for
it's
part
used
1.
Also for part 1 because you have to apply the instruction to the position.
Yeah, this will take a given instruction and mutate the current position according to the instruction itself.
Question: why are we using usize? Just curious.
But because the submarine can't jump out of the water, it's not a dolphin. So it can only going forward. Yeah. It can only be in the water, and can only go forward because there is no backward in the instruction set. So
okay, fair enough.
It's a good question, though.
As a dolphin. It could work for airplanes then, yeah.
Thomas is also saying that static means that compiler put the static string somewhere. So it's probably going to be embedded in the binary. Also, hello, Kelvin. Good to have you here. Hopefully, you'll find this interesting. Let us know after the stream. And feel free to ask any question if something is not clear. Okay, so leaving the dolphins aside, this, what it does, it gives us an easy way to multiply the two values, and also it can apply any structure and mutate itself. As you can see, this is mutable. So that means that when you call this function, it will change the inner state of the structure.
Now I have a stupid question. That at this point I must know, but I don't remember. Origins and depth are private to the class, so you can only access them with helping functions, or you can access them from outside.
So you can make them public like this.
Okay, so by default they are private.
But the scope is not the function itself, but it's the module. That basically means that if you export all this code as a library for like third-party users,
from outside you can't touch them, but from inside the library you can refer to them directly. They are not shadowed in any way. Okay, so it's private, but not at class struct level. Sorry, but they are
at file
private
level.
at module level. Okay.
Or at least this is my understanding. It might be a little bit more nuanced than that. I think if you have multiple levels of packages, maybe there are exceptions. But I think this is at eye level the rule.
Okay, thank you.
Okay, so now I remember how I implemented this one, which maybe is not the most sensible solution in Rust, but it was fun to do it this way. So let me know what you think. But basically what I did, I created so if you have we are implemented this from iterator for position, which is basically something that allows you to call collect. You have an iterator and you can call dot collect at the end of the iterator. And basically by implementing this trait, we are telling you can collect into a position structure. So basically what we can do is we can say all the lines, map them one by one to instructions, and then call collect.
Okay.
And you get already a position that
So
has applied all the instructions.
The collect must be called on top of a collection of instructions, not a collection of strings.
Yes,
They must
let's
be already
actually
passed
see part
outside.
one. Part one becomes literally this. You take the input, you take all the lines, you map them doing a parse so that you actually get instructions, instances, and then you just collect.
There is not a way to map without doing the closure. I mean, I remember that we did something like filter map and just passing the wrap. I don't remember. We did something.
There might, I don't know if it works here because we need to pass, we need L.
Okay. But yeah, but you can, map takes a function, right?
I think we might be doing something like this. I'm not sure this works, but there might be a shortcut like this. Oh, but then you still need to unwrap, unless you need to do another step of mapping.
Filter map or map filter is not doing the unwrap for you? There was not a command to do that? No, I'm remembering wrong.
Yes, no, there is something. You can do filter map, and then you need to use is okay, I think, to convert an error to it's filtering it or not, to an error to an option, basically, I think.
Okay, let's go back to what it was.
I think it will be more complicated here. I think this is a little bit more linear. And also the semantic is slightly different because it means this unwrap will actually fail if one line is not compliant. If you do that filtering, you are ignoring
it. You
errors.
just discard it. Yeah, depends on how strict you want to be.
Exactly. Yeah.
Also, to somewhat answer, I'm not sure if Thomas was asking, but the starting point is 0, 0. That's 0, 0, 0.
Not 0, 0, true.
Yeah, you only have forward and up and down. So you have two axes. Okay, so let's look at this one again, this from iterator, which again is basically just a trait that if you implement it for a struct, it will give you the ability to collect an iterator into the struct. So I don't know if this is a clever idea or if, I don't know, maybe there are other implications. It just sounded nice to use from like the exercise perspective. You just say dot collect and everything else is done for you. So what I was doing is I created a new position default, which is basically 0, 0. And then, because by the way, this is something I didn't mention, the position here derive default and usides is 0, usides is 0. So if you do this, it's going to apply the default for every field. So that's how we magically get 0 and 0 to be the defaults. And then what we do is for every structure in that iterator that we are getting as an input, just call apply with that instruction. And at the end, return the position.
Yeah.
Cool.
Make sense?
Yeah.
It does.
Cool. So that's pretty much it for part one. So if we run the test, let's see if it works.
First of all, it compiles.
Because I updated Rust, so I don't even have the dependencies cached anymore. Cool, so that's working. Yeah, Tommaso is rightfully saying that we could have used fold or reduce rather than that collect trait.
Sure.
again, maybe that would have been a more meaningful approach. I don't know, more sensible approach. It just was fun for me to experiment with the collect API, which I haven't used before.
In the end, I think from the complexity point of view or speed, it's not changing a lot.
It's just preference.
Yeah, I don't know if this semantic makes sense. Like if you would expect that by calling collect, it applies every single item in the iterator, and then you get the result.
Normally, the collect is a changing type of a collection. What do we use that? What is the normal use in Rust for a collect?
The ones we have seen are, for instance, you have an iterator and you want to accumulate all the results into a vector, for instance, or a set or an hash set. These are the cases where we used it. Yeah.
You don't collect to a scalar, but you collect to another type of container.
Exactly. So that's why maybe it's not the most intuitive usage of this functionality, but it was interesting to play with it.
I think a fold would be a bit more explicit because you could see like position apply the parsed instruction. But if it works,
I don't dislike the approach.
No, just it's more explicit. That's it. I'm not saying it's good or bad. It's just clearer to literally read. It's calling this apply.
Yeah, I think semantically will be a little bit more, I don't know, obvious, because when you do fold, you are generally reducing a set of values to one value. When you do collect, is generally just put them into a specific container. So, but I don't know.
Do we want to commit because we have a change to the error messages? Right, we have them as static now.
Let's do very quickly part 2 because I don't think it's going to take longer, and then we commit everything.
Coolio.
Okay, part 2, I think it's pretty much the same. Let's read it because
they changed the rule a little bit.
As usual. So basically what we do is, based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The commands also mean something entirely different from what you originally thought. So down increases your aim by X units. Up decreases your aim by X units. Forward does 2 things. It increases your horizontal position by X units and increases your depth by your aim multiplied by X. Make sense?
Yeah.
So it's like wherever you are pointing, you're going to move in that direction.
It changes your tilt, and then based on that tilt, you go without trigonometry involved because thank you.
Okay, again, down and up do the opposite of what you might expect. There is an example. So literally, we just need to do the same thing. What do you get if you multiply your final horizontal position by your final depth? So the exercise is literally the same. We just need to take into account that the instructions are doing different things and that we have an additional dimension, which is the aim.
So our struct will have an additional field, our state will have this additional field, and the instruction will be handled differently. So you did another type? Oh yeah, you did another type.
That's what I did, position with aim. So this is the only difference with the previous one. And then there is an implementation. Multiply is the same because that wasn't changed. The apply is slightly different, and this is where the business logic lives. And here, if you go up, you decrease the aim by the value. If you go down, you increase the aim by the value. If you go forward, now we do 2 different things. We increase the horizontal position by the value, but we also increase the depth by the aim multiplied the value.
Cool.
Then what did I do? I did the same. I did
another
iterator approach with collect, and this is literally the same code. Now, here there could be an interesting opportunity for some optimization, but let's run the test first to make sure it works, because everything else is literally the same. We are just collecting into position with aim and here position. Okay. Cool, that works. Now,
And you say that the code is exactly the same for those two stuff. Is possible to have some kind of inheritance like in Rust?
And this is the same question that Tommaso is asking, I believe. Now, this is actually, let's do it because this is interesting. This is something I did actually with Tommaso once while we were working in a library. And there is even a video on the same YouTube channel if you're curious, where basically what you can do is that when you have a common behavior between structs, there isn't inheritance like in Java or other object-oriented languages, but you could define a trait that says, this is a behavior that certain structs can implement. In our case, the behavior could be this multiplication, for instance, result, or this apply. Like the functions we have here, they could go in a trait of its own. And
multiply makes sense because multiply is exactly the same. Apply is different, so we can keep it different.
But the behavior is the same. Like the signature, if you look at it, is the same.
Yes, but internally they are doing different stuff. I mean, they are treating the comments in a different way.
This is also interesting because what we could do is to have a default implementation for this one in the trait itself and leave this one open to implementations.
Okay.
Then what we could do is when we implement this from iterator, we could implement it for the trait itself, or better, for a type that implements that trait, because the only method we are calling is literally apply. So that's already codified in the interface. And then Rust at build time will do all the monomorphization of that. But we don't need to repeat this code twice. We don't need to repeat this code twice. And this one will be the only thing we have to rewrite for the two different structs.
So in the end, Rust, when it's going to compile this, it will multiply all the possible traits and creating in reality the classes, but just not, we don't have to write them. It's at compile time that those classes will, struct, not classes, sorry, again, the struct will be created and populated with the methods and everything else. Okay.
Yeah, I think it will be clear once we write it down, but basically Rust will see that you are calling a method which has generic types, and it's going to see, okay, in this context, you are actually using this instance for the generic type, so I'm going to generate all the code for that particular type, and it's going to do it twice in our case, because we are going to have only two different types that implement that generic trait.
Depends if, Tommaso said, that depends if we are using generics, like you explained, or dynamic dispatch, that I have no idea in Rust what it means.
Actually, this is another good thing that we could do today. It's very easy with this example. But yeah, that's a very good comment. It's basically, Thomas is saying that this is one way of doing it. When you use the trait and you let Rust at compile time to generate the code only for the types that you are using, which makes sense when the scope of your problem is limited. But let's say that we were creating a library. Yeah. Maybe we wanted to do something a little bit more generic.
In that we want to take everything that has an apply function.
Exactly. Or maybe another case could be, for instance, you want to have a collection of items that could be both position and position with aim mixed together. So in that case, you need something more dynamic where Rust is not going to generate. Maybe I'm going to be saying something not strictly correct here, but the idea is that Rust is not going to generate all that code in a static way, but it's going to have a mechanism to define the type of every single
like a little bit
item.
Of reflection.
Exactly.
It takes the parameter, do a little bit of reflection on that object, is structed, say, okay, is this type, I will do this. Okay.
My knowledge goes so far to say that it uses a mechanism like a vtable with fat pointers, where it's going to create pointers. In that pointer, you're going to have the actual address, but also a value that tells you which V table has all the details of that particular type. So it's like saying, I know the type from the pointer, and then I have all the data pointed by the pointer.
And which one of the two do we want to try now?
We can try both because I think the difference is very subtle, and we can even test the performance, I think.
Okay. I have to agree, I'm sort of lost with everything you said. So
yeah, I think now
that
we write the code, it's going to be easier. So the first thing we want to do is to define the interface, right? So what do we call it? Movable, I guess. Maybe.
Submarine.
I would call it dolphin, but yeah.
Dolphin.
Let's
or not
call
a dolphin.
Like a dolphin. Let's call it submarine, maybe. And let's pretend we have two different models for a submarine.
Yeah, there's submarine and submarine luxury or whatever. It also has aim.
This is something we can literally copy, I think. Do we?
Yeah, but
I
would know the name of the variables.
Yeah, I think we can do that only if we do something like this, fn orids as a function that returns usides, and of course need to have a reference to self, and the same with depth. And only at this point I think we can do this. Okay, because of course otherwise there has no clue like what self.orids means.
At that rate you can't force to have some kind of variables struct. You can only force to have them to have functions.
And you can have associated types, but I don't think you can force attributes. I've never seen that. Maybe I'm wrong, but I've never seen that.
It does kind of make sense because you want structs to be basically dynamic structures, or not dynamic structures, but structures that you can define. And the moment you start enforcing stuff, you kind of lose that.
So let me see if I understand this suggestion from Tommaso. We can split that into a concrete structure with horizontal and depth and a dedicated enum. Okay, I'm not sure I'm following, but I suppose another approach will be not to provide a default method and let the user implement this multiply by themselves.
And then we'll still have to implement it twice. Right?
Or we can do two things. We can do two different traits, because multiply in the end, we don't really need to abstract it, to be honest. Maybe submarine can only have apply or move if you want, whatever.
Yeah, okay. Yeah, the multiply is a convenience method. It's still an interesting problem how you could implement this.
Oh, okay. Tommaso is suggesting struct submarine T, horizontal usides, depth usides, enum T. And that enum T will be what? The different model of moving around, I suppose. Like either is with aim or without aim, right?
Can't a T be pos and pos with aim? No, it's not possible.
That's, I think, what they're saying, right? It's going to be one of, basically.
Okay, let's go with this simple approach first, and then we'll see if we can refactor. But basically, this will be the other functionality. Now, arguable whether you just want this one in the submarine or not.
Why not? You apply the instruction to the submarine and it moves. Makes sense.
No, I'm only thinking that if we have to implement this thing twice, one per structure, then let's just remove all of that, and it's easier to just implement this once for twice.
Let's stay just with the trait submarine that implements.
Let's just do it, super simple.
Apply.
Let's call it movable submarine, and we call this one move. So, move is a private word.
Apply,
apply, it's apply. Nice. Then let's just call it submarine. It's fine. Okay, so now what we want to do is for position, we remove this one from here. And what we want to do is implement submarine for position. And this is going to be forcing us to implement that method. So if we don't do, it's going to complain. And this is the signature. So I'm going to copy paste all of that here. And
So now
similarly, we'll need to do it for this one, position with aim. We can remove this one from here, and we can say implement submarine for position with aim. And the same story.
Okay, now our from iterator for submarine.
Now we can remove this one because it will become a duplication, and we need to write only one, which is this one for some. I think we need to say for. I think it looks like this. So we need to say T submarine. And then for T, I'm not sure if that's the right syntax. Oh yeah, there is a double T.
Still not happy.
So what are you trying to say? You say implement for this trait the from iterate for the from iterate. Oh my god! Implement the from iterator trait on an instruction to the trait submarine.
Yes, I don't remember the exact syntax that we might have to figure out. So it's basically saying for any generic S that needs to implement
submarine, we can implement the from iterator.
Maybe we can just say for submarine, and that would be enough. No? Or for
a dynamic submarine.
Yeah, there is a way to say that. So let me see. If we just do S, what is that gonna do? Okay.
Instruction insert the enumerator, the enumeration must go in int12.
That shouldn't matter.
No, okay.
I'm thinking.
So.
Okay, let me do a Google time.
Yeah, it's Google time. Let's see our Google skills.
Exactly.
The Rust type system is incredibly strong.
Yeah, you can do crazy stuff.
But sometimes explaining what you want to do with classes is like a catwalk on the keyboard. It's like a bunch of single quote stuff, angular brackets.
I think we're just not used to it, man.
No, but I think that also coming out, inventing a syntax that is machine is easy to parse, human readable, and makes sense to the machine is incredibly hard. I mean,
yeah.
I am happy to accept suggestions if anyone has done this before.
Can only suggest Googling it, but you're already doing that.
Okay, let me check something else.
Because the next step is inventing another language just to define the types, and then a language to write the methods. But I think it's a little bit overkill at that point. It's nice to have everything in the same file and not having different files with different meanings. And UML tried it and failed.
Almost there. Give me a second. Okay, let me see if we can use this one here. Oh, how can you create a new tab in this view? Okay, whatever.
Control T, I don't know.
Does it work? Does it let you add the URL? It doesn't. Thank you,
Control
Google Chrome. Nope. Okay, cool.
Perfect.
I'll do it in a different way.
So here we are trying to implement the from iterator trait for another trait.
Yes, and I have an example here that I'm trying to get. So this is the one we were working on with Tommaso some time ago. And we literally did this thing, but I totally forgot how we did it.
Where?
So there is a thing that is called query stringable. The idea here was that we have a bunch of different objects. All of them can be serialized into a query string. So we defined a generic trait that you can implement. So if you are query stringable, it means you can take any of those objects and convert it to a query string parameter. So the trait is saying as query string as query param. So this is what you need to implement, and you return a vector of essentially key value pairs, right? That
And
will go into the
5?
query string. Now line 5, yeah. For instance, we did this: implement query stringable for every option that is where T is query stringable, right? Which means if it's some value, then use as query params on the value. Otherwise, it's an empty vector.
Okay, makes sense.
So
Now,
this is how we are using dependent types together. And this one is for vector, which basically means take all the values in the vector that are query stringable and build one single query string with all those values.
But this is a trait that you defined. We want to use the trait that we defined that is submarine in conjunction with the from iterator that is a trait defined by Rust. Right?
Exactly. So that's why I was thinking this as a submarine for S. But then what do we need to return? S here. Is that going to work?
POS is not of type S. Or it is. Yeah, it is.
That's what we want, that it returns something of type S.
Actually, S isn't even a type here, right?
It's a generic type.
Yeah.
So
but what you were doing there was
back to the
code, maybe just once.
So what you were doing there was an option of this thing, which was an actual type. It's an option of a generic.
But let me actually read the error, then maybe we can learn something. Type parameter S must be covered by another type when it appears before the first local type. Instr. Implementing a foreign trait is only possible if at least one of the types for which it is implemented is local. Is there an example here we can look at?
Ooh, you might want to zoom in a bit. Yeah, thank you.
Okay.
Okay, error. We are in that first example. Error. Cool.
Perfect. Yeah. This is literally our issue, right? For my type 2. But
and
this
now
is...
do you fix it? Just switching the order. You have to put comma S in
but
the
again,
after instruction.
This is for types, not traits.
Yeah, exactly. Let's see if there is another one.
I don't think it's happy to implement a trait for a trait. I found a post on a forum on Rustlang, and from 2017, so it's, you know, pretty old, but they were saying you can't do a trait for a trait.
Is it?
I can send you a link. Here.
So if after instr in that from iterator you put comma S, what's happening? On line 53.
Comma S, but this is not the same thing. Because from iterator is another external trait from the core library that we are trying to use.
Okay. So I was just curious.
Starting to think that the fold/reduce method might have been a bit
Was better, yeah.
less code, easier to follow, Although this has its uses in other places,
So we landed and we discovered that implementing a trait on top of another trait is not that easy.
I think it is possible, but
we don't know how to tell Rust to do that. Instead, the dynamic approach at this point.
the dynamic approach still requires you to do something like this.
Yeah, but if you remove that, it was suggesting you something about, and you do for submarine. Instead, you remove implement as submarine.
Okay.
he tried that
And
earlier,
you do for submarine. It was suggesting you about dynamic, I think, about using of din.
So din, is that going to work? Oh yeah, now here we need to do self, I think. The size value, is that the syntax? Maybe it's like this.
The master says
Okay.
we can't do that.
Okay, we also have here, hello, Electrizitas. I'm not going to be able to pronounce that, but yeah, it's asking what we do. We are trying to solve advent of code in Rust as an excuse to learn Rust. And now, like right now, we are stuck trying to refactor something and make it a little bit more generic from our solution.
Also, line 555, we define a POS. So we use the type POS. But one time will be POS with aim and the other time will be POS. So we have to have a different type there, like...
right, so that needs to be something like S default. I don't know if we can do that because it needs to be passed in somehow, right?
Yeah, it sounds...
Or self. And if you want to do self, you need to say that like it needs to be something like this, that S is submarine plus default, I think.
And then we have to do S default and pass back the return an S.
No, it's back to earlier when it was not happy.
Yeah.
In short, we're trying to implement a trait for a trait, by the way, just to clarify a bit more what Luciano answered earlier.
But we have no idea how to do that.
We're not super sure if it's doable.
Yeah, I was quite sure it was doable, but maybe I'm wrong.
I think we can go back to the previous implementation with the copy and paste.
Yeah.
And maybe do a fold.
Yeah.
And that's it.
But even leave how it was that was working and jump it on the next exercise, and leave it open to somebody in the audience if they want to send a pull request with a trait that implemented on top of a trait.
Please do. If any of you knows how to do that, yes, please do. Curious to see.
Yeah, I'm really curious.
Or just open up a pull request saying this cannot be done.
Or maybe we just need to say inst as well. That's it. Must be used as the type parameter for some local type. Okay, so it cannot be just a trait. There needs to be some wrapper.
Some wrapper around the trait.
Know, struct, pos, wrapper.
That is of type, that is a submarine.
T, and then pos T, and we can even say that T needs to be a submarine. I think if we do that, it's a little bit convoluted, to be honest. let's call it P at this point.
I definitely prefer the fold at this stage.
Actually, at this point, we can say for
Post wrapper.
post wrapper. Yes. And now the problem is that this is not going to be self, but it's going to be S default. Oh my God. And then why this doesn't work? Oh, this one doesn't need to be there, I think. Yeah, and now we need to return post wrapper of post.
Curly brackets post. So you can do that by wrapping your trait.
Yes. Now, is this ugly? Probably yes.
Yes, a lot.
But at this point, what we can do is literally this post wrapper post. That should work, and then it's post 0.
It's not called post. It's not post.
Sorry, yes, yeah, this is super
Post
ugly.
post.
Tommaso's also saying we can put the coordinates into the post wrapper, which is fair. It's
Probably
a local
makes
type.
sense, yeah.
Yeah, but let's see if these work like that. At least I can
more
confirm that I
intelligent.
understood what we did.
Yeah, now this will be post with aim, right? And here we do the same, post.mul, and I think this will work now. I know it's ugly, but it should work. Yeah. Correct.
Okay. So you can put a trait on top of a trait, but only if you wrap it into a type that is just used to refer to the trait that you want to implement for, because you can. Is that for the problem? The on line 57 for this can't be a trait, must be a struct.
Exactly.
And then is a struct that has to implement the trait submarine.
That contains an item which can be that submarine.
That must be considered a submarine. Okay, oh my God.
Okay.
It works. Cool.
Yeah. Do we like it? I don't know.
Definitely
I'm not super sure that I like it, but okay. Probably
I would like to keep this as a note somewhere. Because if we ever do run into somewhere where we need to implement a trait for a trait, which sounds a bit strange, I guess, but it'd be good to remember it and to kind of have you can only do it with a, wrapper. On the other hand, I would much rather implement and commit to a repo, a fold instead of this. I think it would make everything...
Yeah, this is the reason why this one was working, because here option is a wrapper, vector is a wrapper for the type.
Yep.
Yeah.
So, okay, cool. Good to know.
Lesson
I don't
learned.
know what we do. We just delete it and do a fold, or do we want to do something else?
Make a branch, commit to a branch, and then go back to the previous branch and merge it.
Okay.
Keep all of this in a branch.
I didn't commit this one, so let me copy paste, because when we go back, I want to keep this one.
Yeah, fair enough.
So, new terminal. Please give me a new terminal. With
traits.
Mega traits. Oh, I need to
-b.
Yeah.
Ugly.
With ugly traits for traits. Not force.
Yeah. Don't lose your copied stuff.
I'll take it again.
Yeah, fair enough.
It's here.
Guys, install a clipboard manager.
Mhm.
It's 2022. You have to install a clipboard manager
I
that
know,
keep the last 50 copy and paste.
Or just
Is-
use Vim.
It's probably the last 5 years that Roberto is telling me that.
Yeah.
Okay, so
Oh, you
now
use
we do.
Vim, you hit the wrong button and you delete all the file, then you close your laptop and you go to bed.
That's true. I was only joking, man, with the just use Vim. But it does have, multiple buffers.
We want
Anyway.
to do this one.
Yeah.
Now we commit.
Check if the tests are still green, just because paranoia. Just for
CD
that.
year 2021, exercise 2, cargo test. Still green.
Okay. Sorry,
Nice.
paranoia is with me.
Cool. So what do we do next? We have 2 minutes, so we can either call it a day
Let's
or
do the
try to
poll.
do something else.
I think we can call it a day for today.
Okay.
Alrighty. So who wants to do the closing?
I'll do it. So, all right. Well, thanks everyone for following along. We're gonna wrap it up. This means we're going to put the recording on YouTube. The link to the YouTube channel is on the Twitch in the About section. If you're watching this on YouTube, we live stream every morning at 6 p.m. Irish time. Sorry. Make sure to check out the link Twitch in the YouTube description and follow us so you can be notified when we stream new stuff. Feel free to leave comments or open PRs. We should have a banner for the GitHub repo now. And everything's well accepted with those PRs. Like we said earlier, if anyone knows of cleaner, better ways to do trait for trait, that'd be cool to see. Cleaner, nicer, more readable, whatever you have better, do share it with us. We're still learning Rust, so don't expect these solutions to be amazing or the best and the most idiomatic ones. If you have better ways of doing things, do let us know so we can learn. Thanks everyone for the suggestions and collaboration from the chat. That was great. And we're gonna raid someone now, I think, right?
Yes, we are gonna raid Jonathan Blow, who is a famous game developer. And sometimes he's also building his own programming language, which is called Jai. So that might be interesting for somebody.
Cool. Thanks everyone.
Bye.
See you later.